At first, nothing looks unstable. The room is loud in the ordinary way. Belts move. Tools answer back. A clerk looks up from a desk. Someone wipes a hand on an apron. Heat sits behind a wall where it has sat every day before, so familiar that no one grants it a thought. Then the wall stops being a wall. It jumps. Brick bursts outward. Iron tears loose, like it has changed its mind about staying solid. The floor lifts. Windows become knives. Dust eats the air. And the force that was supposed to stay trapped in one obedient place suddenly takes the whole building with it. In the street outside, people who were not part of the work are thrown into the same disaster anyway, because the blast does not care who was on shift and who was only passing by. What looks like a freak catastrophe is really something colder than that. It is a machine doing exactly what it was always capable of doing. That is the part history keeps softening. These explosions were not acts of chaos arriving from nowhere. They were the final sentence in a long argument between usefulness and containment, between the demand for more output and the material limits of iron, water, heat, joints, bolts, welds, valves, habits, and money. By the time a boiler let go, by the time a pressure vessel turned a workday into a crater, the failure had already been developing in places no one could see, without stopping the whole operation and admitting that the giant in the corner was not simply productive. It was conditional. It was temporary. It was aging every hour it did its job. And that leaves the real question, the one bigger than any single blast. If the danger was built into the system from the beginning, why did people keep building their lives around it? Because for a long stretch of modern life, these machines felt less like options and more like the foundation under everything else. They broke older limits that had ruled work for centuries. Power no longer had to wait for a river, a wind change, an animal team, or a human back. Once heat could be captured and pressure could be directed, motion could be summoned indoors, on demand, in bad weather, at night, in dense blocks of brick and stone where older sources of power had never fit cleanly. That changed the scale of production. It changed how high buildings could function, how fast goods could move through rooms, how many tasks could be tied to one engine, one shaft, one schedule. What mattered was not just that the boiler made power. It made centralized power, and centralized power reorganized entire ways of living. So the machine spread. It moved from mills to workshops, from workshops to laundries, from laundries to hotels, from hotels to ships, basements, plants, public buildings, and crowded blocks where heat and work and traffic all touched each other. Employers depended on it because it compressed labor. Owners depended on it because it multiplied output from a fixed footprint. Workers depended on it because wages followed the places where power gathered. Cities depended on it because convenience has a way of becoming invisible just before it becomes essential. Very quickly, one sealed vessel in one room was no longer serving one task. It was tied to a network of routines, payrolls, deliveries, tenants, deadlines, and families waiting on the week's pay. That is when a machine stops being a tool and becomes a point of failure large enough to matter far beyond the room that contains it. And the design choice at the center of all this was both brilliant and unforgiving. To be useful, the stored force had to sit close to the people and processes that needed it. Distance wasted power. Distance meant more piping, more loss, more cost, more delay, more reasons not to install the system at all. Efficiency demanded proximity. Put the boiler near the engine, near the floor, near the rooms being heated, near the work being done. And the whole arrangement became compact, profitable, and fast. But that same decision placed compressed danger inside ordinary life. It put stored energy under stairs, behind walls, beneath offices, below rooms where people slept, beside corridors where messengers crossed, next to streets where children and shoppers and drivers had no idea how much violence was being held in place by metal, attention, and luck. The system worked because the force was close. It killed because the force was close. A boiler does not look dramatic when it is doing its job. That was part of its power over the imagination. It was heavy, often still, often tucked away, more like infrastructure than a machine anyone watched with awe. Yet the whole arrangement was an argument against stillness. Fire worked one side, water answered, heat moved through plate and seam. Pressure climbed inside a chamber whose only purpose was to resist the pressure climbing inside it. Gauges translated invisible force into a needle position. Valves promised release if that force rose too high. Feed systems tried to keep water at the right level. Operators listened for changes in rhythm, watched for a tremor in the needle, a hiss where no hiss belonged, a wetness around a fitting, a hammering sound in a pipe, a patch on the shell that held heat differently than the rest. Every part was leverage. Every part was also a weakness, waiting for the wrong combination of temperature, neglect, and time. Because the visible machine was only half the story. The other half lived inside the metal and behind the habits that surrounded it. Normal operation did not merely use the boiler, it changed it. Heat cycles expanded and contracted plates. Water left scale. Corrosion ate where eyes rarely rested. Sediment altered heat transfer. Low water exposed surfaces that should have stayed cooled. Repeated firing and cooling created fatigue. Repairs introduced new joints beside old weaknesses. One hurried patch obscured a crack, but concentrated stress somewhere else. The very fact that the machine survived yesterday encouraged people to believe it would survive tomorrow under the same strain. That is how false confidence accumulates, not as recklessness announced out loud, but as routine. A day without failure becomes evidence of safety, even when it is really only evidence that the countdown has not reached zero yet. Safeguards existed, and that is what makes the story worse, not better. Relief valves could vent excess pressure. Gauges could warn of dangerous conditions. Inspections could catch weakness before rupture. Operating rules could keep water level, firing rate, maintenance intervals, and load within sane limits. Insurance inspectors could force discipline where owners would not. Regulators could set standards for thickness, workmanship, testing, and training. But a safeguard is only as real as the system around it. A valve can be undersized. A gauge can be wrong. A test can be delayed. A report can be softened. An inspection can be rushed because stopping production costs money right now while future failure remains abstract. Operators can be overworked, undertrained, ignored, or blamed for conditions they did not create. Safety layers look solid on paper because paper does not have to withstand heat, pressure, and payroll at the same time. The first warnings almost always arrived in forms that invited dismissal. A strange vibration. Water where it should not be. A sticking valve that freed itself. A seam that sweated and then dried. A pressure reading that seemed high but returned to normal before anyone else saw it. A sound like knocking from inside the shell. A temporary drop in performance explained away as fuel quality, weather, load, bad luck, or operator error. Each anomaly was small enough to survive as a story instead of a response. No single moment seemed to justify shutting everything down. Yet the pattern was the message. When the same kinds of warnings appeared across different rooms, different buildings, different operators, they were not random. They were the system trying to confess through symptoms. What failed was not only metal, it was interpretation. And once you start looking across multiple accidents instead of one, the pattern becomes impossible to ignore. In one building, a vessel burst after being run harder than its condition could bear, proving that demand could outrun judgment. In another, poor water level turned ordinary firing into a hidden emergency, proving that the danger could build under apparently normal operation. Somewhere else, corrosion and deferred maintenance transformed a manageable defect into a structural break, proving that decay was not cosmetic. In another case, a safety device existed but had been compromised by habit, misunderstanding, or economy, proving that equipment meant nothing without enforcement. Then there were the blasts that tore through walls into streets and nearby rooms, proving that the casualties would never be limited to the crew nearest the furnace. Different sites, different details, same logic. The hazard was broad, knowable, and repeatedly underestimated because sharing the full truth threatened business before it threatened memory. The actual moment of failure is brutally mechanical. First comes the breach, usually small in geometry and enormous in consequence. A crack opens along a seam. A plate gives way where it has thinned or been overheated. A joint separates. The vessel's containment drops in an instant from absolute to partial, and partial containment is no containment at all when the contents are under pressure. Water that had been held above its normal boiling condition suddenly finds a path to freedom. Pressure falls. Superheated water flashes into steam with explosive speed. Expansion does the rest. The rupture tears wider because the escaping force creates its own enlargement. What had been stored quietly becomes motion, shrapnel, impact, heat, collapse, and overpressure all at once. The machine does not explode because fire leaps out like a bomb fuse. It explodes because containment fails, and the contents transform faster than the structure can survive. That is why the aftermath feels larger than the object that caused it. The shell becomes projectiles. Walls cease to be supports and become debris. Floors lose the relationships that made them floors. Air itself turns violent, carrying dust, glass, splinters, brick, plaster, heat, and sound into bodies that never agreed to enter a pressure system. People nearest the rupture are hit first by force and fragments, but others are injured by collapse, fire, panic, smoke, blocked exits, and the destruction of the ordinary paths that usually save them. The blast moves outward into adjoining rooms, then into stairwells, storefronts, streets, and surrounding lives. One machine failure becomes a neighborhood event because buildings are not isolated boxes. They are connected spaces, and a city amplifies whatever breaks inside it. That is how a giant hidden in a basement or plant room can erase more than a room. It can erase confidence in the idea that walls are enough. So why did the cycle continue even after enough ruins existed to make the lesson obvious? Because incentives are often stronger than memory, while the danger remains invisible. Output had to continue. Payroll had to be met. Contracts assumed uninterrupted work. Owners had capital tied up in existing systems. Insurance logic sometimes improved discipline, but it also translated catastrophe into a cost category, something priced, negotiated, and managed rather than treated as a reason to abandon the underlying arrangement altogether. Secrecy protected reputation. Reputation protected revenue. Revenue protected delay. Even the people who feared the machines could not always demand their removal because the machine was also the source of employment, heat, and local survival. Once a city organizes itself around concentrated power, stopping the system feels like self-harm, even when the system is already injuring people in slower, quieter ways. There were attempts to solve the problem without surrendering the advantages that made the problem attractive in the first place. First came better construction and clearer standards, thicker plates where needed, stronger joints, more disciplined testing, improved manufacturing, better understanding of water level and heat stress, stricter expectations for fittings, valves, and workmanship. That reduced some failures because ignorance is always the easiest thing to remove. Then came stronger inspection regimes, licensing, insurance pressure, maintenance schedules, and operating procedures meant to catch hidden weakness before it turned violent. That reduced some failures too, because neglect thrives where no one is forced to look. But neither answer removed the core condition. The stored force still sat indoors. It still sat close to people. It still relied on containment, remaining perfect long enough to be called safe. Progress narrowed the window of disaster. It did not close it. The deeper solution arrived when power no longer needed to live as pressure in the room where work was happening. Once energy could be generated elsewhere and sent where it was needed through safer, more flexible systems, the old giant lost its monopoly. Smaller distributed machines changed the risk map. Motors that did not require a giant vessel of superheated water beside the workforce changed building design, changed maintenance, changed fire load, changed who had to stand next to what in order for daily life to continue. Standards evolved with that shift. So did design philosophy. The lesson was not simply build the old thing better. It was stop placing so much stored violence so close to ordinary human occupancy when another architecture of power is available. Replacement mattered because it changed the relationship between usefulness and blast radius. Even then, the legacy didn't vanish with the machine's decline. It remained in inspection culture, in pressure codes, in engineering conservatism that looks boring right up until it saves a building, in the insistence that convenience is not proof of safety, in the understanding that hidden systems deserve more scrutiny, not less, precisely because daily life depends on them. It remained in the body count history, rarely recites in full, in streets that were repaired, in businesses that reopened, in families that had to continue after the room at the center of their income became a crater. It remained in the institutional memory that every powerful technology writes two histories at once, one of what it makes possible and one of what it makes inevitable if nobody respects the conditions that keep it contained. That is the warning inside the story of these silent giants. The danger was never only the boiler, or only the pressure vessel, or only the blast that finally announced itself. The danger was the bargain people learned to call normal. Keep the system close, keep it running, trust the gauge, trust the schedule, trust yesterday, trust that the hidden force serving the city will remain a servant forever. For a while, that bargain built wealth, speed, and modern life. Then again and again, it erased rooms, workers, passers-by, and whole sections of the built world to remind everyone what had actually been placed behind the wall. The lesson is not that power is evil. The lesson is that concentrated power always asks where its consequences will land when containment fails. And if that question is not answered honestly, the city answers it later in brick dust, twisted metal, and names no one planned to add to the record.